pleasure, runs the Joint Institute for the Study of Atmosphere and Oceans at the University of Washington, where he's also a professor of atmospheric science. He used to run a magnificent program at the Department of Energy called ARM, which used to actually try and see what the Earth was doing energy-wise as it's monitored from space. He was also, with his colleagues Richard Turco, Brian Tu, Jim Pollock, and Carl Sagan, the author of possibly the most influential single scientific paper of the last 50 years, which was the paper which introduced the concept of nuclear winters to the world. So, Tom, please.
Thank you, Oliver, for the kind introduction. On behalf of my colleagues, I'm not sure that we would agree that was the most influential paper of the last 50 years, but it was fun. I'm going to speak standing up. I'm a professor. That's what we do. I should also warn you that professors are well known for speaking 50 minutes exactly, because that's the class time. So, in the late 1800s, a group of German farmers and their families moved to the state of Illinois, which is in the center part of the United States. They were attracted to the state of Illinois by the Homestead Act. The Homestead Act allowed a head of family to settle on a piece of land. It was a quarter section in the United States, which is a half mile by a half mile, 65 hectares in size. If they lived on that land for 5 years and improved that land, and that's what the Homestead Act said, improve the land, they were given title, they owned it. By improvement, what they meant was primarily cutting down the trees, plowing up the prairie, and converting it into cropland and pasture. Two of the children of that group of German farmers were my grandparents. So I am a child of the Anthropocene. They were busy terraforming the earth. I entered graduate school in atmospheric sciences in 1971 at the University of Washington. The first project that my advisor handed me to look at was a paper written on the effect of stratospheric transport airplanes on the ozone layer. The paper suggested that these fleet of aircraft would harm the chemistry of the ozone layer due to nitrogen chemistry. That chemistry was in fact formulated by Paul Crutzen about 2 years earlier. The same year, a conference report emerged from something called a study of the man's impact on climate that identified threats to the global environment due to human activity. These included carbon dioxide emissions, effect on climate, the effect of aerosol primarily on human health, and the stratospheric ozone threat. My PhD dissertation, influenced in large part by these kinds of material that I had studied, was on the effects of pollutants on urban climate, which was at the time, I must admit, a very obscure topic. Over the course of my career in atmospheric sciences and climate, the collective wisdom of my field, of the scientists in my field, is that we now are we are absolutely certain that human activity is affecting climate. So I've gone over the course of my career from speculation to complete certainty. So, does this mean that we have entered the Anthropocene? I don't know. As we say in the United States, answering the question of naming geologic ages is above my pay grade. I do know, however, that the realizations that humans can alter and are altering the global environment changes the perspective of environmental scientists on how they do their work. And so what I'd like to spend the next few minutes is talking with you about how I might see my career differently if I were starting over today. Thomas Kuhn, the great philosopher of science, introduced the idea of paradigm shifts in science. I'm not a great fan of Thomas Kuhn, but I think we are in a paradigm shift right now for environmental scientists. I think we are thinking differently about what we are doing and how we are doing it than we were doing 20, 30, 40 years ago. Climate science has largely been what I will call an observational science, and I'm using the word a little loosely. But what I mean by that is we are like astronomers. We go out and we observe what nature gives us. We then try and understand the processes, we write down equations, we build models, and we solve them. I difference here this from laboratory science, where in the laboratory you create little worlds. And you modify those worlds, and you play with those worlds, and you try and understand the processes that govern these worlds. So what we're now doing when we talk about geoengineering, when we talk about controlling the climate, is moving our field of environmental science from being observational to being a laboratory science. And where's the laboratory that we're talking about? Well, it's outside those windows. This is a very different idea. Maybe a scary idea. I want to note before I go on that we humans have been geoengineering our environment for a long time. All we need to do is think about dams, the great dams of the world that have been built to control floodwaters, to provide water for irrigation. In creating those dams, we've destroyed habitat, we've killed animals, we've changed the nature of the earth. However, we're now talking about doing this on a spatial scale and perhaps a temporal scale. That's much greater than what we've talked about doing before. So let me present a few thoughts on being a participant rather than an observer, and how that changes the way I think about my research. These ideas are only half formed at the moment, so I hope you'll give me a little latitude for things that I have not thought deeply enough about. In the work that I do with a nonprofit, I am fond of announcing that budgets are a moral choice, are moral documents. How we spend our money is a measure of what our values are. So, as a scientist, we often argue that our research is led by curiosity, or by the best idea, or the best hypothesis that we have. Given that many of us see climate change as inevitable under the current business as usual, the way that the world is working at the moment, I now wonder if there's a moral imperative that dictates what we should be doing with our research talents. Are we to use our research talents as making a moral statement? Should we be focused on climate change research, including geoengineering, to the exclusion of all other ideas? On the opposite side, or sort of flip side of this, are there topics excuse me, that we should not even research because they may give aid and support to policy options that many think are wrong? This is, of course, the moral hazard argument. Should I not study what I'm interested in at the moment, marine cloud brightening clouds over the ocean as a way of reflecting solar radiation and cooling the planet? Should I not study that because it might work? And if it works, somebody might want to use it. I don't know. I obviously think that I should, but this is a personal choice that derives from my own sense of morality and the ethics of the society in which I live. I want to note that these choices are complicated by the fact that we can never predict where research is going to go. Oliver mentioned my nuclear winter research, and I will point out happily that when this was first suggested to me, I said I didn't want to do it. And I said I didn't want to do it because I was afraid my estimation, my quick estimate, was that there would be no effect. And I wanted in no way to encourage people to think they could use these weapons. Turned out I was wrong. There's a huge climate effect. So I didn't know that at the time. There's another issue here of risk and uncertainty. As we move towards intervening in the climate system, we move towards research that is more risky in every way you can define risk. How do we determine that risk? How do we balance the trade-off between risk and reward? How does the uncertainty in what we know and don't know play into the assessment of risk? These are incredibly difficult questions. We, as environmental scientists, don't even have a framework in which to answer these kinds of questions. We are not going to develop that framework by ourselves. We need help here from social scientists, from philosophers, from economists, and dare I even say it, lawyers. Sorry, I'm a scientist, we don't. To lay out a framework and define what we mean by risk and reward. Briefly, on prediction and simulation. As climate scientists in my field, we have distanced ourselves from the weather forecasters. All right, weather forecasters are in charge of making a forecast about the weather tomorrow. Climate scientists are making forecast, only we don't like the word forecast, prediction, simulation of what climate's going to do in 20, 30 years down the road. And we were always safe with that because nobody cared. Well, now people care. So how do we understand now what we mean by prediction? How do we assess the uncertainty in our predictions because society wants to know these answers? There's an entirely different view of what we mean by prediction in climate now than there was when I started working on these problems. I might also point that evaluating these predictions is an incredibly hard problem. If I look at my young colleagues, I'm not sure that I want to encourage them to go into it because there may not be an answer, and what might that do to their career? Lastly, I want to talk about developing technology. There's a famous American line about baseball, from a film about baseball, in which it says, "If you build it, he will come." Now, this was mentioned earlier in talking about Frankenstein and technology. We have a disturbing habit of using technology if it's available, regardless of what the moral rights and wrongs are. So, again, we are faced with this issue, and for someone like myself who's been involved in developing technology that's been used on satellites, technology that's been used to observe the atmosphere from the ground, I'm now looking at technology that can be used to modify clouds. How do I understand the line between science and technology, between doing a simulation of geoengineering in a computer and exploring my ideas in the real atmosphere? Is there a line? Where is that line? How do I know where that line is? The biomedical community has faced many of these issues, but some of them are unique to the geoengineering problem, and one I want to mention in closing. Biomedical issues are to a large degree personal. They are intensely personal. They're about what I do with my body and what you do with yours. As we think about global climate intervention, we were faced with the challenge of trying to decide what we should do, not on the mores of me personally and the society in which I live, but in the global context. Who gets to decide which set of mores, which set of values are the ones that we should use? We all know, we can all look around our world and we can see what happens when deeply held values collide. So, this is a collection of not fully developed thoughts. I realize I'm in a different age. Call it the Anthropocene if you want. To me, the issue is not the name. The issue is, how do I respond to it as a scientist, really realizing that the world in which I now live is a world in which my science, my technology, has the ability to change that world, perhaps for the better, but perhaps with unintended consequences, much for the worse in ways that I don't know. These are thoughts that are rattling around in my head. I want to thank Mark Lawrence for instigating the conference and asking me to be on this panel. I would not have volunteered for it, but he's been interesting. Clive Hamilton will be up here shortly, and I want to thank Clive for the book he has written on Earth Masters. I don't agree with Clive on everything in the book, but it's a good read, and if you want to think about these issues, it's a good book to start with. I also want to thank two of my colleagues at the University of Washington, Rob Wood and Steve Gardner, for many good conversations we have had about geoengineering and how we should do it. Thank you all for listening.
Thank you very much, Tom. I'm sure the students who get the full 50 minutes enjoy every moment of it. Tom went on to try and steal some of my job by introducing Clive Hamilton, but I'm going to do a little bit of that too. My friend Clive is an Australian public intellectual of global significance, I would say. He's a leading thinker on the Anthropocene, its implications, and I think quite crucially in this context, its discontent. He's a former director of a progressive think tank, the Australia Institute, and he's currently the Professor of Public Ethics at Chester University. Clive.
Thanks very much, Mark. Oliver, for that introduction, and Mark for the invitation and for convening this fabulous conference, which has been a wonderful success. Well, in the 17th century, at the dawn of the modern era, The English scientist and philosopher Francis Bacon had a vision to use science to found what he called an empire of man over nature. He saw technology as the transformative power granted to humans by God. For men like Bacon, remaking nature could redeem humankind from the biblical fall and the misery of the world that followed. Technology and science would bring about what he named a second creation. Bacon is perhaps most famous for his fable, New Atlantis, published posthumously in 1627. In the story, a council of wise men rule over a lost island. The wise men send out envoys to gather knowledge from other parts of the world, knowledge that they can use to make a new Eden in imitation of the first act of creation. Bacon referred to this council of wise men as Solomon's house, or the College of the 6 Days' Work. The college serves as keeper of the know-how to transform nature. New Atlantis was one of the first visions of the perfection of human society by means of the conquest of nature. Scientists would become utopia's midwives, and throughout the history of modern science, many of its leading practitioners have been eager to assume the role. Bacon's ideas were subsequently developed and applied in many ways, from early improvements in English agriculture to the ideology of manifest destiny in the United States, the belief that animated the 19th century conquest of the American West. There were resistors and objectors to the march of technology, romantics like Wordsworth and Thoreau and the young Goethe, whose lyrical warnings about man's corruption of nature have inspired modern environmentalists. But the momentum of technological industrialism, while occasionally in some parts of the world slowed, has always rolled over any protest. The vision of a second creation reached its secular zenith in the United States in the decades after the Second World War, energised perhaps by the undreamed of power of nuclear fission that lay at the very core of the military-industrial university complex. The deep roots of techno-utopianism in the American psyche help, I think, to explain why faith in geoengineering is stronger in the United States than it is in Europe. And we're now witnessing a recovery of the idea of a second creation in the reframing of the Anthropocene as an event to be celebrated rather than lamented or feared. Instead of final proof of the damage done by human arrogance, a new breed of eco-modernists welcomes the new epoch as a sign of our ability to transform and control the Earth. Gathered around organisations like the Breakthrough Institute, they see the new geological epoch not as evidence of humankind's short-sightedness or callousness, but as an opportunity for humans to realise their full potential. American ecologist Earl Ellis, for instance, defends what he calls the good Anthropocene. There are no planetary boundaries, he wrote, that limit continued growth in human population and economic advance. Human systems can adapt and indeed prosper in a hotter world because we are masters of transformation. At the very end, the last couple of paragraphs of his recent book, David Keith writes of his excitement about using solar geoengineering to transform the Earth, and of his, quote, delight in our new tools. So 4 centuries after Francis Bacon, these new Prometheans believe that with modern science and technologies of Earth system engineering, and especially climate engineering, we finally stand ready to build the new Atlantis. We will be proud of the planet we create in the Anthropocene, declares Earl Ellis. Only romantic critics of technology and the gloomy scientists they quote and support stand in the way of the vision's realisation. Just as Francis Bacon understood nature as a passive object to be manipulated, put on the rack, he famously said, in order to extract her secrets, Once those secrets have been extracted, he saw the exercise of human creative power face